properties of the definite integral. When we define the definite integral of the function f of x dx, which is going from a to b, we implicitly assumed that the lower limit a is less than b. But the definition as a limit of Riemann sums makes sense even if a is greater than b. And notice that if we reverse a and b, then delta x changes from b minus a over n to a minus b over n. So therefore, if we have an integral that goes from b to a of f of x dx, well, to change these limits to make the lower limit a and the upper limit b, if we do that, we need to apply a negative symbol. So now we would have the negative of the integral from a to b f of x dx. Now, if we know the fact that a is equal to b, meaning that both of these limits, the upper and lower limits, are the same, then delta x is going to equal 0. And so therefore, if we have an integral that has the same upper and lower limits of the function, it's going to equal 0. So again, these properties are important to look at when you're going through some of your problems. Now, we now develop some basic properties of integrals that will help us to evaluate integrals in a simple manner. We assume that f and g are continuous functions. So some of the properties of the integral. So if we have number 1, if we have an integral that goes from a to b of a constant times dx, well, it's going to equal c times b minus a, where c is any constant. Number 2, if we have an integral that goes from a to b of f of x plus g of x dx, well, we can separate this with addition. We can say that the integral of a to b of f of x dx plus the integral of a to b of g of x dx. Number 3, if we have an integral going from a to b with a constant c times f of x dx, we can factor out the constant c, and then we have the integral from a to b of f of x dx, where again c is any constant. And number 4, if we have an integral that goes from a to b of the function f of x minus the function g of x dx, we can separate these integrals and have an integral from a to b f of x dx minus an integral of a to b gx dx. Now, if we look at property 1, it says that the integral of the constant function f of x is equal to c is the constant times the length of the interval. So therefore, if the constant is greater than 0 and a is less than b, this is to be expected because c times b minus a is the area of the shaded rectangle in the figure below. So here is the interval from a to b, and then there is the length of c. So that's the area of the rectangle. If we take the length and multiply by its width, then that would give us the area. That would make sense there for property number 1. Now, property 2 says that the integral of a sum is the sum of the integrals. So for positive functions, it says that the area under f plus g is the area under f plus the area under g. So the figure below helps us understand why this is true. So in view of how graphical addition works, the corresponding vertical line segments have equal height. So again, this is a visual graph of using this property here, which again is property number 2. Okay, next, in general, property 2 follows from theorem 4, and the fact that the limit of a sum is the sum of the limits. So here, if we have this integral from a to b of f of x plus g of x dx, we can write this as a limit as n approaches infinity of the summation of I is equal 1 to n of f of those sample points plus g of those sample points times delta x. And then what we can do is we can multiply through delta x and we can distribute the summation to make these separate. So now we have the limit as n approaches infinity of this particular summation plus this summation of g. And now we can then take the limit of both of those. So now we're going to take the limit as n approaches infinity of this function plus the limit as n approaches infinity of this function, which then comes back to our definition and then what we proved, meaning that the function f of x dx from a to b plus the function g of x from a to b dx. Now, property 3 can be proved in a similar manner and says that the integral of a constant times a function is the constant times the integral of a function. In other words, a constant, but only a constant, can be taken in front of an integral sign. And then property 4 is proved by writing f minus g, which is equal to f plus negative g, and using properties 2 and 3 with c being equal to negative 1.